Good morning, Professor, and my dear friends. Today I'm going to talk about an interesting topic related to semantic segmentation. So, there are a lot of models which actually do semantic segmentation, and one of them is a model which actually uses transformers in order to solve it. It is called as segfarmer. So, what exactly is basically semantic segmentation? So, basically, semantic segmentation tries to solve the problem of classification as well as detection. So, it tries to segment the objects into different kinds of classes which are having similar kind of attributes, and there are a lot of benefits. And one of the benefit over object detection is that it actually in object detection we get a bounding box around the object, but in semantic segmentation we can actually get a clear boundary of that object. There are a lot of applications of semantic segmentation ranging from autonomous driving, medical imaging, geosensing, and there are still a lot of applications that are coming up. A quick background of semantic segmentation. So, it was actually divided into two different kind of approaches. One of them is a traditional approach, another is a deep learning approach. In traditional approach, the semantic segmentation is being solved using different kind of algorithms like clustering algorithms, region growing algorithm. While in deep learning approach, the problems of semantic segmentation is being solved using fully convolutional neural networks as well as transformer based networks. So in order to compare segfarmer, like in this slide, I actually showed you the different kind of the models that were actually being used and their performance. So quite like a history about using transformers in the field of vision is that actually the transformers were used to solve like a sequential kind of data, and they were introduced in the field of NLP. So one such paper that deals with using transform in the field of like vision was vision transformer, and in that paper they what they have done is that they have actually cut the images into shorter images, and they have fed this data to the transformer in order to get the output. But there were a lot of drawbacks of this kind of transformers. One such drawback was that the decoder part of this transformer was very large, as well as the kind of positional embeddings that were utilized were of fixed size. But if the images were of different kind of scales, this kind of positional embeddings will just fail. And the another main drawback of this kind of transformer was that it just focused on the encoder part and it just neglected the decoder part of the transformer. So in order to solve all these issues, the segfarmer transformer network was actually it was used, and it has actually two main models. So the first model which I'm going to talk about is the hierarchical transformer encoder model. So what it does is that it is a kind of encoder of the transformer, and it has been actually quite been inspired from the encoder part of the vision transformer, but there are quite of changes that they have actually used incorporated in this kind of in the encoder part. One such change is that they actually use hierarchical feature representation. So this kind of feature representation is seen in the CNN as well. So for example, in CNN there are different kind of layers, and in different layers different kind of features are being processed. So in the earlier layers, lower layer of features are getting processed. In the later layers, higher level of features are getting processed. So this kind of hierarchical feature representation as well as the self-attention part of the transformer is also being made more efficient. So in general, the self-attention layer is of the order of n square, but in this kind of encoder, they have actually reduced the order from order of n square to order of n. So another next part is the all multi-layer perceptron decoder part. So the decoder part actually helps to maintain the larger receptive field, and it is very important to maintain the larger receptive fields because it helps to extract a lot of features if the receptive field is large enough. And there are like main four features of the decoder. So in the first layer, it actually unifies the channel dimension of all the features from the encoder. In the second layer is basically does the upsampling and concatenates all these features, and in the last layer it basically fuses all these features. So as mentioned in the paper, the training details of this segfarmer are been shown in this slide. So it was actually trained on segmentation code base. The encoder part was actually pre-trained, and it was trained on ImageNet 1K dataset. The decoder was randomly initialized, and it was actually the optimizer that was used was Adam optimizer with a having a batch size of 16, and the learning rate was a variable learning rate, and they have actually trained it for around 160k iterations on different kind of data sets. So as you can see, this is the kind of data output that you can infer from seg former. So in order to understand how the this seg former is performing, you can see clearly see in this chart that the mean intersection of union, which is a metric that has been that is being used in order to compare the semantic segmentation models, is much higher as compared to different kinds of models which are actually trying to solve this problem. And as well as there are actually the number of parameters and the flops that this model actually being utilizing is very less as compared to other models as well. So it is also compared with on real time as well as non-real time for with different kinds of models. Like so you can see the FPS as well as the mean intersection of union is much better as compared to other models ranging from the fully convolutional neural networks, deep lab v3 plus, as well as other transformer neural networks. So in order to conclude is that seg former is not perfect, but it is like much more simple and like cleaner as well as much more powerful as compared to other transformer networks that has been used to solve the problem of semantic segmentation. And there are a lot of like changes that they have made in the encoder as well as decoder part, ranging from the change like variable positional embedding feature as well as the hierarchical features representation in the encoder part, which makes it more efficient, as well as they are still actually trying to like improve it so that it can be deployed on edge devices, because the number of parameters that it has been currently like generating, it cannot be still deployed on edge devices, but it is still achieving great results as compared to other state of art models. Thank you.